Hi everyone, today I'm going to show you the continuation video on how to solve this heat equation using numerical approach. Okay, the numerical approach that we're going to consider is explicit 4-point. So if you look at this heat equation here, we have the initial condition. This is my initial condition, which is at t equals to 0. Okay, now these are the boundary condition. Here we have the boundary condition when x equals to 0 and x equals to 1. Okay, the length of the grid is from 0 to 1. Okay, so what we have here, we have a non-zero boundary condition. So we are solving for non-zero boundary condition. Our boundary condition are not 0. Okay, so given h equals to 0.1 and k equals to 0.001, so we know that x equals to m times h and t equals to nk. So we want to find the solution for this value at k equals to 0.01. So this means when n is 1 times k, this is my t. Okay, so we want to find all this value. So this value here, like I say, this value here can be obtained when x equals to 0, which is you can use sine pi t. Okay, so sine pi t. Similarly, for this value here, it's obtained for x equals to 1, which is cos pi over 2t. Now, the initial condition when t equals to 0 can be obtained, all this value here. Yeah, they are obtained by using the initial condition. So at x equals to 0.1, x equals to 0.2, and so on. Now, what we are interested is actually to find all those black values here. Okay, so to find this, we are going to use the 4-point explicit method. So let me just label this. So this is my u when m0 n0. This is my u m0 n1. This is my u 10 u 10 Now the initial condition u10 u20 u30 u40 are all this value at this point. Okay, u50 u60 u70 u80 u90. Okay, they are this point value here. Okay, now this n equals to 1, m is 1, so u11, this value here will be u21, this one will be u31, this one will be u41, u51, u61, u71, u81, and u91. Okay, so in the previous video, I have shown you actually all these initial condition values and the boundary values. So today I'm going to show you how to find this one. Okay, so the notation we have here, so we have u, m, n. We can write it as u, m, comma, n with the same u, or we can also write it u, x, t. These are the same condition. Okay, now we are using the explicit 4-point scheme, which is given by u m n plus 1 equals to r u m minus 1 n plus 1 minus 2r u m n plus r u m plus 1 n. Now remember, my r, what is my r? So we don't know. So r equals to k over h squared. So if k is 0.001, divided by 0.1 squared. which is 0.1. So I put it in, I will have 0.1 u m minus 1n, so 1 minus 2r, 1 minus 0.2, 0.8 u m n plus 0.1 u m plus 1n. Now this is a 4-point scheme. Okay, 4-point scheme. So you can, on a computational molecule, I can write it as here. Okay, so what happened here? So if this is my 0.1, 0.8, 0.1. Okay, this is for n plus 1, n. Okay, and then this is for my m minus 1, m plus 1. Okay, this is the value that we want to find, which is my u m n plus 1. Okay, n plus 1. By taking this combination. So in other words, if I look at this diagram here, back to my this diagram, if I want to find u11, u11 equals to u00, 0.1 u00 plus 0.8 u10 plus 0.1 u20. Okay, let me just write it down. So we have u11, which is 0.1 u00 plus 0.8 u10 plus 0.1 u20. Now these values are from the initial condition where we have obtained earlier on. See the initial condition when x equals to 0.1, x equals to 0.2, and x equals to 0. Okay, now how do you find u21? u21 will be, okay, which is when m is 2 and n is 0. Okay, so we have 0.1 u10 plus 0.8 u20 plus 0.1 u30. So if I look at my diagram here, to find u21, I need u10, 20, and 30. Did you see the scheme here? This is exactly the same pattern like this one. Okay, now to find u31, we need 20, 30, and 40. Okay, so we have u31 equals to 0.1 u20 plus 0.8 u30 plus 0.1 u40. Okay, so I can also find u41, which is 0.1 u30 plus 0.8 u40 plus 0.1 u50. Now u51, 0.1 u40 plus 0.8 u50 plus 0.1 u60. Now we have to find all this value. Okay, so you can refer to my my textbook here. So all this value can be found by substituting the values at the initial condition. I mean, for initial condition when x equals to, this is the value for x equals to 0.1. This is the value x equals to 0. So this is x equals to 0, x equals to 0.1, and x equals to 0.2. Okay, you just put it in. Now, since this is symmetry, so u61 will be the same value as U41. U71 will be the same value as U31. And U81 will be the same value as U21. And lastly, U91 will be the same value as U11. Okay? So it's not that complicated. So our idea is we need to fill up all this value. We need to obtain all this value for t equals to 0.001. So you need to find all this value. Okay? So like I said, this value you can obtain by the right hand side boundary condition. This is obtained when using the left hand side boundary condition, which is this. So when t equals to 0, sine 0, and t equals to 0.001. And this one, same as well. Okay, so I guess that's all. So you can, if you have the whole picture on how to find this, you can try to work this on your own. Okay, so yeah, there's a few things I would like to say. If the question asks you to find for k equals to, let's say, k equals to 0.002, what that means? Okay, it means that we need to find one more layer up. Now this is t equals to 0.002, so we need to find all this value here. Okay, I'm just giving you a brief idea here. Okay, and the concept is still the same. So to find this will be let me just erase this. So this point here will be U12. To find U12 will be 0, 1, 1, 1, 2, 1. So 0.1 times this, 0.8 times this, and 0.1 times this. To find this value, which is my U22, will be a combination from U11, U21, and U31. Okay? And so on. So I think you get the idea here. So read the question and see which interval or which solution you want to find, and then work on the grid accordingly. Okay, so that's all for today's video. I hope to see you in my next video. That's all. Bye.